Okay, so let's look at this. In this example, what we're going to do is we're going to take this function g of x and we're going to rewrite it in this form. We've done this before. So when we did this previously, the way we did this is we used synthetic division or long division to do the rewrite. In this case, we're going to do it in a different way. So let's see what we got. So we have our function g of x. Now, before we even really start with this, I want you to kind of think about the numerator. So what I'd like to be able to do is I'd like to, from the very start, I'd like to be able to cancel out a common factor from top and bottom. But currently, I can't. Okay? Currently, there's no common factor on top and bottom. But I want you to notice something. What if I were to, so I'm going to make a change here, but this is not part of the problem. I'm kind of thinking this through in my head here. So the stuff on the right, it's not really part of the problem. So what if I could just magically change the problem a little bit? What if I were to change the problem so that the numerator, I change that 5, actually, let me do this in blue. So I took that 5 and I magically changed that 5 to a 3. Okay, this is just through the use of magic. I'm just imagining what's going on here. So I took that 5 and I just changed it. Notice why that would be nice. So if I were to rewrite this, I could then, in the numerator, I could factor out a 3 out of both terms. Oh, and look how fantastic that is. There's an x plus 1 in both terms, and I can cancel out. So wouldn't it be great if I could just change this 5 to a 3? Well, you can, and I'll show you what I mean by that. You can't do it through magic. You got to use some properties of math, but we'll do that. So what I'm going to do is I am going to subtract 2 from 5, right? Because if you subtract 2 from 5, you get 3, but you can't just subtract 2 because you're changing it. So I'm then going to also add 2, and this is the key. Notice negative 2 plus 2 is 0, so my numerator has not changed at all. It's the same thing. I've just taken 3x plus 5 and added 0 to it. And the advantage to this, as hopefully you can see right off the bat, is then I can rewrite this as 3x plus 3 plus 2. So note all I did here, right, was I combined these two to get 3. From there, what I'm going to do is I'm going to split this up. So I'm going to write this as 3x plus 3 over x plus 1 plus 2 over x plus 1. And think about why I can do that. When the denominator is the same, what do we do when we add? We keep the denominator and add the numerators. I'm just doing this in reverse now. I've added the numerators. I'm now going backwards. And again, the advantage to this, let's keep on following this. The advantage to this is now in the numerator, I can factor out that 3. So I factored out that 3, and the great thing is I have an x plus 1 on top and an x plus 1 on the bottom. So I am left with, don't want to do this in red, I am left with 3 plus 2 over x plus 1. Okay? I'm not going to worry about graphing this one. We've done a lot of graphing at this point, this type of function, so we should be okay with it. Notice that we have a vertical asymptote at -1, we have a horizontal asymptote at 3, and we have a vertical stretch of 2. Okay? But that being said, That is how we rewrite a function in this form to this form.